Hello and welcome to this section of the tutorial. In this section what we're going to do is begin to talk about fractions, but more importantly I want to introduce to you something called the Symbolic Math Toolbox. And it takes a few minutes of explaining for me to convey to you what exactly that is and how important that is. First things first, everything we've done so far in MATLAB has been numerical. And what I mean by that is it functions much like a regular old calculator you get from the grocery store. You type things in, no matter how complicated they are, and you get decimal answers. 108 plus 109. You wrap these guys in parentheses. Yes, MATLAB does understand parentheses, but ultimately when you divide by 7 or something like that, what you're going to get is a number. Let me retrieve the last command by going up arrow, divide by, 18, and then you get a decimal. So so far it doesn't seem that MATLAB really understands fractions or fraction simplification, because if you look at this guy, 108 plus 109 over 18, or we can just take an easier example. Let's do something like 22 36. This is a fraction we know can be simplified. We know we can divide top and bottom by 2. But when I put it into MATLAB, it always gives me a decimal. And that's actually fine for most cases, because most of the time in MATLAB, when you're using it, you're doing a simulation or you're crunching numbers and you're really just trying to converge on a numeric solution. When we get a decimal like this, it's called numeric solution. And so, that's just what you're trying to do. So that's the strength of MATLAB. But many cases, especially students, you want to keep everything in fractional form, or what we call in more general terms symbolic form, where you're not talking about 12.0566, you're talking about some fraction. Or when you do other problems involving differentiation or integration, you may not want a number, you may want an actual expression as the answer. And so far we haven't talked about that at all. Now, if you just purchase MATLAB, what you're going to get is what we're working in here, MATLAB, and what you're going to get is these decimal answers. But there are these things called toolboxes which can be added on to MATLAB to expand its capabilities. Now, if you're a student at a university and you're using the MATLAB installed in the computer lab, or if you're a student at some university and you've purchased MATLAB in the student license, then you automatically get all these toolboxes. One of these toolboxes is called the Symbolic Math Toolbox. And basically what it does is it gives you extra commands to be able to do symbolic math, to handle fractions purely, and to do algebra basically, where it can handle expanding polynomials and things like that. It can do symbolic math. So if you're a student and you purchase a student license, you already have this. If you're a professional working in a company, you may or may not have it. It just depends on what your company purchased. So the way you check is, if you notice at the lower left-hand corner, there's a Start menu. If you click that Start menu and go up to the top, it'll say Toolboxes, and when you hover over it, notice it says Symbolic Math. That means that on this computer I have MATLAB installed. I also have the Symbolic Math Toolbox installed. Now, I'll take a minute to tell you there are tons of additional toolboxes that you can purchase for MATLAB. And again, if you're a student, you probably have quite a few of them already. There is a statistical analysis toolbox that gives you extra commands with statistics. There is a communications toolbox that gives you extra commands if you're dealing in communications theory. There is a control systems toolbox that gives you extra commands if you're really doing a lot of control system stuff. So that's sort of the big picture, but what we're going to use in this section and for the rest of the course is I'm going to teach you a little bit about how to use this Symbolic Math Toolbox. Now, you don't really need to use the Start menu for anything. When the toolbox is installed, those commands are available in the MATLAB window automatically. And the most important one that we're going to use is called SYM. SYM. This stands for symbolic or symbol. So let me clear the screen like this. Now, notice if I type in, let's say 1/4, like this, into the MATLAB window and hit enter, I get 0.25. If I type SYM parentheses 1/4, or 1 divided by 4, and I wrap this number inside the SYM, what it tells MATLAB to do is, don't treat this as a division problem and give me a decimal. Treat it as a symbol. And what I mean by that, it's just a math object, right? The fraction 1/4. That's what I want you to do. So hit enter. Notice we don't get 0.25. It just gives us an answer of 1/4 because it didn't divide this and give us a decimal. It's telling it to treat it as a symbol, a general mathematical object, right? So I can do this for any sort of division. I could say 3/10. And of course, it's not going to give me a decimal back. It's going to give me the fraction back. All right. So what happens if you go symbol, and if you go, let's say, 1/2 plus 1/4, and I wrap this addition of these two fractions inside of the symbolic operator. And you know what? MATLAB perfectly understands that this is 1/2 plus 1/4. If you want to put a space in here to make yourself feel comfortable that this is 1/2 plus 1/4, you can do that. That's going to be fine. When you hit enter, MATLAB's going to add these two things together, not as decimals, but as fractions. And notice that it gives us 3/4. And notice also that there's no common denominator here. The 2 and the 4, they're not the same. So MATLAB found the common denominator, it added the numerator, simplified the result, and it gives it to you in the simplest terms. It's always going to try to give the fraction to you in simplest terms. All right, so here's basically a cheap way to do fraction arithmetic in MATLAB. So you can wrap it inside of the symbolic operator. If you prefer, you don't have to do that. You could do symbol 1/2 plus symbol 1/4. Notice this is accomplishing the same thing. It's just I have a symbol that I'm calling 1/2, treat as a fraction, treat 1/4 as a fraction, add the results. And we get the same answer, 3/4. So it's two different ways of accomplishing the same thing. One way we put it inside one symbol operator, another way we put it inside of another. So let me clear the screen. I always like to do that when I'm messing around like this because it keeps things nice and clean. Let me go back for a second and show you what happens when you take 1/2 and add it to 1/4. What you really get is 0.75. Notice we didn't have any symbol wrapped around anything, so MATLAB went ahead and just calculated the result numerically for us. Now notice, if I do symbol, SYM, open it up, and type in the last answer, remember the last answer, ANS, is a variable. It's right over here. The current value of last answer is 0.75. I can use ANS in any calculation that I want. So in this case, I'm going to take ANS, which is 0.75, and I'm going to throw it into the symbol function, and whenever I get is a fraction, 3/4. So that is really, really neat. You can, if you're working in MATLAB and you have, let's say 78, 102nd, 78, 102, that's the final result of your calculation, and you get an answer of 0.7647, and you're like, oh man, what is that in fractional form? You can just do symbol, last answer, and then you'll get an answer of 13/17. Notice that is a reduced form of the original fraction. So somehow MATLAB is smart enough when you, and I have to say it's pretty slick, when it does a numeric division like this, it gives us an answer, and there may be more decimals past this, more decimal spots past the 4 digits that's being displayed to us. We'll talk about precision and displaying precision in a little bit. But somehow it captures a more fundamental representation, of this division inside of itself. And if you ask to convert the answer to a symbol, it has enough information to go back and reconstruct everything and give you a fraction. So that's a really great way to work with fractions. Now let me clear the screen. Now notice you don't have to keep this to simple fraction problems. What if you wanted to do something like symbol, let's do 2 raised to the 4th power, because we learned how to do exponents in the last section, divided by 44. I wrap this guy up in parentheses just to make it clear to you that I'm taking 2 to the 4th power, I'm taking that result, I'm dividing the answer by 44, right? And I've wrapped the entire thing in the symbol operator. So what we get is 4/11, 4 divided by 11. Now let me retrieve the last command by up arrow. Now let me take that symbol thing away. So I'll take that away. So now we have this calculation. Notice the answer is 0.3636, and there's probably other decimals that are going on, but MATLAB's only currently displaying 4 digits after the decimal spot to me here. So the first time we asked MATLAB, give us a symbolic representation of this calculation, so it's going to try to keep it in fractional form. Second time we said, okay, forget about the symbol, just give us the decimal. And of course, since now the last answer is 0.3636, we can do symbol last answer, which is now going to take the last answer and try to convert it to a fraction for us, and we're going to get an answer of 4/11. Now I want to draw something to your attention that I haven't so far. Let's do this numeric calculation again, the one that's just saying give us a decimal. Notice over here in the workspace window, the last answer variable is represented by this little square thing, and it has a specific value. And if you scroll over, it has a min and a max value, and it's all the same number. It's just because you got to remember MATLAB is going to be dealing in general in terms of lists of numbers. Since there's only one number here, the min and the max is basically the value that we have. It's not like a listing or anything like that. So this is typically what we've been doing in MATLAB this whole time. You know, when we divide things, 3/7 or whatever, the value of the last answer is a decimal, right? Now, if I take symbol and convert the last answer to a symbol, so in this case, it's going to take 0.4286 and convert it to a fraction, and I'm going to get 3/7. Notice this changed over here. The icon changed to like a cube, and the value is not really given to us. The value says it's a 1/1 symbol. And if I scroll over like this, the min and the max isn't even really listed here. So what I'm trying to let you know is that the icon over here, this little cube thing, can be used to tell you what type of variable you actually have. The value here, notice it says SYM for symbol. So what it's telling you is currently the last answer, the value of the last answer, or the whatever is stored in the last answer, is a symbol variable. And it's totally different than a decimal variable. It treats it as a pure mathematical construct. It's going to try to use the rules of algebra when dealing with symbols to simplify things, basically, right? So no matter what you're doing in MATLAB, if you go over here, 4 divided by 5, then that's going to change to an actual value. And that's something that you can see here is actually a concrete number, a decimal number. And if you ask it to change to a symbol, it's going to be reflected here. So later on in the course, when we have lots of symbol variables running around, you'll see them with this cube icon, and it'll say 1/1 symbol. By the way, 1/1 symbol just means you got to think in terms of a matrix. Again, MATLAB, Matrix Laboratory. That's what MATLAB stands for. Everything's a matrix. So in this case, this symbol variable is a 1/1 matrix, really. Just one element, in other words. One row, one column. That's what 1/1 means. So don't get scared off if you see this. It just means there's one element in this thing, and it's a symbol.